So we are going to start a bit early, I guess. Good morning. Thank you for coming. I'm Julie Mullen. I did this work with Lauren Edwards and Vijay Gadapalli. This is primarily work we had done as we built out a course. So I come from MIT Lincoln Laboratory. I should say at the outset that we are a very small team, so we are a little bit intimidated by all the pieces that we saw yesterday where these big teams got all this stuff done. But what I want to start with today really is what our goal at Lincoln is. Our goal is to take people who are professional engineers and scientists who came out of school, but there's a gap between what they came out of school with or they've come from another company and the information they need to be successful in programs and projects that have very short time horizons. And so we want to build courseware to fill some of that gap and to educate not only our staff, but also government partners. So the talk is going to cover three primary areas: the challenges to course creation, a case study, and finally the lessons that we learned. So MIT Lincoln Laboratory is owned and operated by the Massachusetts Institute of Technology. We're all familiar with MIT. It's an academic environment. But MIT Lincoln Laboratory is a Department of Defense-sponsored, federally funded research and development corporation center. And so what that means is it's going to affect what our role as staff are. So what we do is we exist between academics on the one side, where you're doing a lot of basic research and you're doing training, and industry on the other end, where you're creating products. So we take the basic research and we make some sort of realization. We do a lot of prototyping. And that's really what distinguishes us both from academics and from industry. So, and furthermore, as part of our mission, we support a broad range of Department of Defense missions. We do a lot of evaluation for them. We do a lot of rapid prototyping. We hold conferences and workshops, and part of our goal is to take some of what we do in the workshops and put that into a platform that's far more extensible and scalable. Because we actually have other jobs that we have to do, so we can't be doing teaching the way an academic would. We have university affiliations. Obviously we're a part of MIT, and finally we're a trusted government advisor. And in this final role, we also want to be able to provide education and training on topics that are important to the government. So what does that mean for our staff roles? Our staff roles are primarily doing applied research and disseminating that through conferences and workshops. We brief government leaders on technology challenges and solutions to those, and even sort of like future technology issues. And it's key here, this briefing idea is very key, and we'll come back and see that again. So we mentor colleagues as we're trying to work through, we work everything in teams, so we're mentoring colleagues in the effort of building out programs. Our staff is a mixture of bachelor's degrees, master's degrees, and PhDs. So let's contrast that with faculty. So faculty have as their role, depending on the school, you can argue to a greater or lesser degree, teaching is part of their job description. They do research, they're doing basic research, and they disseminate that through publications and conferences. They mentor graduate students, they mentor undergraduate students, they lead project teams, they do community service to their institution. Finally, faculty generally hold PhDs. So before we continue, I want to say that in the process of my career, I have been faculty for face-to-face courses. I've taught online courses at institutions, at technical institutions. I have developed the MOOCs at MIT, at the Lincoln Laboratory, and I've been a staff. So I've had all of these roles. What you notice here is that where we overlap with faculty is pretty much that faculty are doing research and disseminating it, and we're doing applied research and disseminating it. But there are other gaps that are there. So what does that mean with regard to teaching? Because that's the piece that we're really interested in today. So faculty have a lot of experience with teaching. They do one-on-one interaction. They do one-to-many interactions with courses. They do one to small groups when they're leading projects and they're working with undergraduates or graduate students. So some keys here are that the courses are generally in a sequence, and the material is fairly standard. So they can fall back on when they took the material, when they taught the material, or when the colleague down the hall has taught the material. They have resources they can fall back on, and they have textbooks. Our technical staff, on the other hand, we've mentored new students, we've mentored new employees, but we're covering topics. There's no textbook. There was no course in a university. For the most part, the courses that we're developing do not exist in a university. And if they do, because they're very narrow topics. So if they exist, they're a very advanced class, or they're offered maybe once every other year, and they're offered on a 14-week basis. And that just doesn't fit what our students will need. So the course material that's covered is generally not part of a curriculum. It's hard to figure out, it's multidisciplinary, so it's hard to figure out exactly what you need in order to be able to be successful. And every time we create the course content, that's the creation of this new library of information. But above all, you can't assume that students come in with prerequisites. The example I give is that people think of engineering as being, oh, you're all engineers. I'm a mechanical engineer. I work with a lot of electrical engineers. We overlap on some topics. We touch on others, and then on the other topics, I'm doing something different here from what the electrical engineers are doing. But if I need to work with them over here, further on in what you get at an undergraduate level, I need to fill a gap. So we can't assume that students have the prerequisites. So basically, at the end, we have the same goal. We want to educate people, but we have different starting points. So let's talk about the student distinctions. Here we get into something that's much closer to college campus students versus MOOC students, and we've all pretty much seen this. So undergraduate students tend to be young, they tend to be full-time, they're building their understanding around something specific. There may be some cross-disciplinary stuff, but it's primarily they focus on a major. Graduate students are full or part-time, they're focused on a deeper learning. Their courses may or may not reflect what they're doing for their job roles. They may or may not align with it, but they are taking a whole program of study because they're looking for a degree. So our students are professional students. They're working full-time. They need courses that are in short sequences. They're generally looking for something that fills a gap of knowledge so that they can be successful. They'll need a refresher, perhaps, or maybe deepen their understanding. They're driven by what all of our online students are driven by. They're driven by personal interest. They're driven by the need for a particular set of skills, knowledge, understanding, so that they can do a work task. Generally not driven by degrees. So this raises the following challenges. And for those of you who are doing this, who are building MOOCs, particularly if you're building them with non-faculty, with domain experts, you've already run into these. So we're back to the brief. So when we have people briefing as the experts, they're up here at 30,000 feet. And so you're looking to abstract it away, and you're looking to say, here's what I've done. Like all the presentations here to this week, here's what we've done. That's not the same as teaching, which we all know. Teaching is at the ground level. So you have to be down in like, this is how we did it, and the details. So we have to take people who are used to talking up here at 30,000 feet and get them into the details without getting into the weeds. So again, our instructors they're expert briefers. But also in a presentation mode, you're expecting people to ask you questions. If at the end or in the middle, they're not quite sure, they're going to ask you a question. If you think back to your best faculty, your best course experience, classroom experience, that faculty member looked around the room, gauged how the student body was responding to the information, and asked questions. and tried to elicit what the state of the students were, how much they understood. We have to train our instructors to think that way. Look around, figure out what students don't know, and figure out what the questions are that you need to ask. This is part of what faculty develop as part of their skill set over years of teaching. And those are the natural breaks, and they're the natural assessments. Finally, we have the other challenges we already discussed, the lack of existing content, and the students arriving with a broader range of competencies. So the strategies to address these: one, we need to shift the instructor focus from the what am I telling the audience to what do they need to be successful. And this new focus then affects the selection of the content you include, the granularity, the method of delivery, the development of assessments, and the interactions, how you're going to build interactions with students. So we're going to talk about modules. I've used modules all throughout rather than, so the Open edX platform uses sections, and we consider that to be a module. Engineers really like to think in terms of components. We like components that all fit together, make a nice workflow, you make a device that works. So for us, components and modules works really well. I want to be able to plug and play with the modules that I make so that I can build other courses and still use maybe some of this material that we created for course A, maybe in course B. So, and in that case, we need to be able to provide as much as the students need so that it will be able to support their environment. Okay, so everybody here, whether you've worked in industry and you're working with subject matter experts, or whether you're in academia, these problems are the same. You know, we were just talking about preparing slides. So content preparation, I think it's almost harder to say to faculty, no, you have to create slides, you should have a script, you should practice your script. Because they still want to take their notes and go to the board and write. And I have to admit, I find that easier, it's less painful, it's quicker. I think maybe industry folks find it easier, a little bit easier to do the slides and the prep because they present more often. So, but you really need to have your script, you need to work with software, and then when you actually create the course, you know, video capture tools, microphone use, I mean, a whole range of issues come up where faculty or our instructors need some support. And the solution for this, or the strategy, is to provide training. The previous speaker spoke about actually building those pieces in so you could support your instructor base. Okay, so let's look at a case study. We started, this is one of the courses that we've created, we started with a 3-day workshop. So you start thinking, or management starts by thinking, oh, you have all the content. You just need to chop it up and put it into the platform. We all know that doesn't work as well as they're thinking it will. So we started on having a workshop where we had expertise from 3 organizations. Each organization covered a day. We used a traditional workshop format like you'd find at a conference. We delivered it via slides and lectures. We provided some examples, and then we had hands-on examples that we worked in teams. The second go-round, we did it all internally. And again, so we reworked the content a little bit. But this time what we did with thinking ahead to the idea that we were going to make actually we were making small privately online courses, that we were going to make a SPOC out of it, we worked with the instructors to say, where are those natural breaks? Build in the natural breaks where you're going to ask questions. Think about this section that you just spoke about. What are the questions? Tried to say, like, stick it in 10 minutes. Make a granularity of, like, 10-minute chunks. And that was our first step at trying to get them to the granularity of the Open edX platform. And our third offering was as a SPOC. So In thinking about the course design, I have a feeling that, yep, okay. In thinking about the course design, I just want to go back and think about the challenges. I highlighted in green the key pieces. We need to be teachers. We need to build in the natural breaks and material review, and we need to remember that students arrive with a broader range of competencies. Okay, with that in mind, starting from the material we already had, we reviewed the material. We said, okay, it doesn't make sense to just break it down based on who's going to talk on a given day. Obviously, that doesn't make sense. So at this point, years ago, I had a very, very horrendous online teaching experience. So I had gone in and developed some instructional design capabilities. I'd actually gone and taken some courses at Harvard Extension for instructional design. And so I sat them down and I was like, oh, I don't know how this is going to go. But we carefully went through and we're building out a sort of a strategy for teaching people. So we reviewed all the material and we started extracting the essential questions. What is it that people really need in this material? And we extracted four essential questions from that material that I just showed you. And that was, what am I working with? What tools should I use? How should I proceed? And how do I integrate it? So you have 4 basic questions. So we use those to develop then our broad themes of the data challenge, system challenge, analyst challenge, and putting it all together. We connected these via a concept map. Now, whether you call it a concept map or a knowledge graph, these are things that are well known in the instructional design community. They're really not well known by faculty on average, and even less well known by sort of domain experts. Fortunately for me, I'm working with engineers. They're very happy with graphs. So this is a very hard chart to read, but basically if you look and you see over in red, we've got our data challenge. What am I working with? Then we've got what tools do I need? Then we have what do I do with them? How do I build it? And then we also have how do I integrate it? And the cameraman's upset because I'm moving around. But basically, engineers are very happy. Oh, it's a flow chart, it's a flow graph. But the concept map is great. You start getting people to understand how to break it out, and we all know that we can see how this would be individual units. So the next thing we did was, in working with them and working with the edX platform, which they were not familiar with, the Open edX platform, we then mapped the concept map over to the platform. Remember, again, I'm referring to this as a module. So we have our module, and we've mapped the main concepts to module, the nested concepts to sections, and the leaves to units. So now they have a mental model. Okay, so then some people are happier with syllabi, old-fashioned syllabi. We map that, module, section, unit. Then we revamp the course. So here's a summary. Again, engineers like flow, we like process diagrams. So here's our processing chain. Took our initial material, we reviewed it, developed our concept map. We sorted the material we already had into concepts, identified the gaps, created the new material, created the courseware. And of course, there's a loop from take and create the courseware, have people test it out, come back, figure out where the gaps are, and go through again. So what are the lessons that we learned? So first, in course design, this is not new to you. Having existing material doesn't mean less design work. Sometimes it can mean more. Focus on the goal. The goal here is to help the student build a mental model. And if you talk to domain experts about a mental model and what they really need, you say to them, you're going to work with this person. What do they need to be successful to work on your project? They can articulate that, and then you can work back from there. Reiterate to them, briefing is telling, teaching is showing. You really need to show it to them. And remember, above all, it's a process. If you can articulate the process to the instructor, they can start to see it. Articulate it through words, through images, and remember to there's a feedback loop. For course creation, script your video. Can't say it enough. Script your video. And I say that because when you practice that script, you discover that the way that you write and the way that you speak, they're not the same. And you start speaking and you're like, I can't say those two words together because I trip over them every time. And so you go back and you edit. And when you do that editing, you identify additional gaps, and you also identify the questions that are natural questions from the material. Build out your slides. It's much easier to control than animations when you're making videos. Take small steps. I mean, we're not at the point, we have a small team, so we can't do real animations yet. Someday. Can't wait for, I want to make radar animations. So take small steps, and remember, this is a process. So, and if you keep telling them it's a process, then they're more comfortable as they come back and they've got their syllabus and, oh, well, we've decided we need to add something new. The other thing I probably didn't put in here is once you show them how easy it is to add and adjust within the Open edX platform, there's enormous amount of relief because it's like, okay, I can always come back and put it back in. It's extremely easy and it makes life much more comfortable for them. Questions? Comments? Observations? Yes?
So what's the lifespan of the content? Do you have content that you think will last for a while, or do you have to go back and revise your courses, your videos, and do you think about that a lot?
So, let's see if it's here. Oops. We have this section in here that says on the horizon. So that's the new technology that's going to come down the pike. We built it in with the idea of we don't want to be redoing this all the time, so you can build it in. That said, we've gotten pretty good at actually creating these short videos. Short videos are easy. The longer ones, you know, this class capture of an hour, that's hard to go back and redo. Especially if you're like, oh, I went the wrong direction partway through. That's very hard. But these short ones are easy. And then I have another course where I built it out. It was our pilot course, and it has to do with high-performance computing. Well, high-performance computing changes. The needs of our users change. So we did it based on use cases and broke it out again small enough that we can go in and update that, especially as we try to abstract away the details and the scary bits of supercomputing. So as you do that, you just like, oh, we can update these sections. And it's very easy. The hard part, of course, is the videos. The rest is easy to update in edX, in the Open edX platform. Yes?
Could you give a perspective of how long this course is in terms of duration, and what will it take for you to create this course in the first iteration, and a year from now, where do you see how long will it take you?
So I have to say that we have a small team, so the three of us were working on building this. I wasn't involved in the initial 3-day event, really, except to be testing examples and such. So I've probably, we have, between the three of us, we've maybe been charging 60% of our time, because I'm actually doing engineering on my other role. So it's taken us about a year, but we're not doing it full time. I think if we did it full time, it would move along a lot faster because we'd be more focused. We wouldn't be coming back to, what were we doing? And we have demoed this a couple of times now, so that we've gone back and said, okay, well, we have to redo that. So we've done some reworked some pieces.
And in terms of the duration of the course itself?
The duration of the course. I expect, so we're actually working on the Analyst Challenge now. We're doing the in-depth, so I know that the in-depth SciDB, that alone is going to be a good solid hour of material, as is the Accumulo in-depth. I think probably all told, it's probably still about a 2 full-day workshop. And that doesn't include, that's to do it. There's also a lot of examples. We have a supercomputing system, so there are examples that will use that system. How long those take people to work through is a little bit is open-ended. So I would say maybe it's still about the size of the 3-day workshop, especially as we add more examples. That's another piece I forgot to point out. getting people to think about good examples. This takes faculty a long time, and a lot of them they pull from textbooks. But when you don't have faculty working good examples that are going to teach you how to do something in the field is really hard. I haven't yet figured out a good way to help people do that. Yes?
I have two questions. First question is, what resources have you found to be useful for instructional design? Do you have any recommendations? Second question is, if your course has a lot of guest speakers, have you run into that issue? So how do you manage that? Any tips?
So the tips on the guest speakers, we've done it two different ways. One way we went and interviewed them, and so someone on the team interviewed, in fact it was Sam Madden and Mike Stonebreaker. So they went and we went to their offices and we just captured everything, and then we went back and I edited it with, I used Final Cut Pro, which was lovely. By the way, Final Cut Pro, if people mess up their audio, oh, it's just, it can fix it, oh. Except for loud Dell machine noise that people are trying to do screen capture with that. But I've had great luck with Final Cut Pro. So the other piece was the other folks we had. So the in-depth is a little more difficult because we actually have had to go and talk to them, and they're creating content and capturing it through Camtasia, and then we will edit that to make it fit. The way that we did that was we showed them what we already had. We asked them for an outline, and we've been working with them to refine that. Fortunately for us, we have two people, one person who has done a lot of videos on how to use Accumulo and Swirl. The other person has less experience, but I sat with him for an afternoon and worked with him, gave him some tips, and then was there to sort of work with him. I would say 1 or 2 hours with people to give them, if you can give these tips up ahead of time, which we're still in the process of putting that piece together, the training materials for, it's great, but you really do need to sit with people when they first start doing the videos so that you can remind them of the things that need to be done. The tools, we use Camtasia Studio. We use a USB microphone with it really gives, it gives great audio. I mean, it's amazing the audio that you can get from the USB microphone. And it's all about audio. It's always been, you know, people will turn off the video and they'll just listen. So the audio is really crucial. We can't use a lot of the open software tools just because of the nature of the work that we do. So I've recently started using Mac Caption. So if people have scripts, this is the other reason scripts are important. If you take your script and you put it through Mac Caption and you add the video, oh, it lined them up. It was glorious. I had to make a few minor tweaks, but it wasn't like typing out what they said and fitting it into a timeline. So those are the tools that we found really valuable. And the Camtasia is great because you can give people a short, like, this is how you use it to capture your video, and then if you do the editing, if you have someone else do the editing, it's just, it's really good. And I've forgotten which USB microphone we have, but I can picture AT2020. Who does that? Ah. But any other questions? Did that answer your two questions, or was there one more that you had? Oh, the instructional design. So we use the concept map. So the essential questions comes from, oh, how can I not remember his name? Wiggins. Wiggins has a book on learning by design, or understanding by design, by Grant Wiggins, and so that whole idea of, you know, what is it they need to know? How do you know they know it? What do you have to put in place? And then someone else told me, I'll look it up for you, find me later, and I'll tell you, because someone gave me another great book on learning, the 7 steps, and it's research-based, so it has all the research articles embedded in it. So. Yes. Nope. Great. Thank you very much.